Welcome. We're here in Grayland, Washington. That's on the Pacific coast. You can probably see the water over there. We're on a DXpedition to catch exotic, faraway, medium wave signals. And that's the house that we're staying in. So we have two antennas here set up in the field. The orange masts that you see are supporting a DCAS antenna. It's 160 feet long. It's basically two deltas, and I'll show you a little bit more about that. In addition, we have a supercas, which is about 112 by 28. That's also right here in the field. Both are fed with a Wellbrook FLG 100, and I'll show you here. That's connected. The wires go into the Wellbrook and they go out into the coax. The coax is about 550 feet or so back to the house over there. So that's pretty long. It's pretty long, but you know, it works. It's no problem. We use these little step-ins, as you can see, for the support for the wires. They're actually pretty handy. They're used for fencing, not the sport, but the fencing of a piece of land or whatever. Buy them at Tractor Supply, I think. Well, I just got mine from Amazon, but whatever. It's being held upright by another guy wire, little guy wire here, to make sure that it actually stays upright. Yeah, so that's the DCAS. I'll walk you through the DCAS in a second. The other thing I want to show you is like the support for the supercas. Actually, I forgot an extra pair of those step-ins to support the wire, so I had to find a stick. But there's plenty of sticks around here. It's it's a beach, so there's like driftwood and everything else. Put a stick down, put a couple of guy wires on there to hold it upright, and then same thing, connected the Wellbrook to it, and the loop, basically. The wires goes back to are being supported by that big kite pole over there. That's the supercas. I don't know did I say super loop? I meant supercas or whatever. But yeah, that's a supercas, as they call it. That's about 112 by 28. This is a DCAS, which is 160 feet long. It's made up of two deltas, and you can see like that's the start where we just were, and goes to the first support. These are kite poles, 28 feet tall. They're supported by a piece of rebar. So what we did is like we put the rebar into the ground, and then slit the pole basically into these like what are they called again? I don't know, fasteners. And that's how it initially stands upright. We put some guy wires on as well to make sure it doesn't fall over. It was quite windy when we put it up, so yeah, it's always a good suggestion to put extra guy wires on these poles. But as you can see, the wire is connected at the top there. So this is the first delta that goes over to the next stepping post right there, where the wires cross each other. That means the wire of the top, basically the top wire, which is blue, goes over into black, and then it becomes your bottom wire. So you get that little cross here. You can see the black wire, which is the bottom loop, goes over into the blue wire, and the blue wire goes up into the air to the second support, which we will continue our trek through the jungle. This area, it's hard to believe, was pretty well maintained, or at least I guess nature maintained itself. It was really flat. There was not a lot of vegetation here, but in recent years it's been overgrown with bushes and whatnot. It's really interesting to see that. Anyway, so we had to hack our way through a little bit, and another piece of rebar here to hold that pole up. As you can see, it's a 28 feet fiberglass pole from Kite Pole. These things are absolutely wonderful. You gotta make sure that you really put your weight into it to extend them. That meaning if you half-assly, I don't know the right word, but if you don't do your best to actually make sure that those connections are kind of like good, then they will fold into itself. Like we had that before. And then I can show you a little bit about the termination at the end. So this goes to the last step in post, which is where the termination is. Now termination is important because you do want these things to be directional. So you have to terminate the back end of the antenna. God, how do I get through here? Okay, plan B, take a different route. You have to terminate the antenna at the back end because you don't want any signals coming off of the back. You know, we don't want signals coming in from like the east. We're only interested in signals coming from the west. So terminating your antenna at the end is mandatory, and we do that with, we do that here with the Vectrol. As you can see, like this is a little Vectrol, which is a remote termination system. It goes into kind of like this control wire. So the wires of the antenna go into the Vectrol, and the Vectrol is being fed. It needs 12 volts, so the control wire goes actually all the way back to the house over there. So that means that we can remotely control it. So that's basically the DCAS. It performs very well. There's absolutely no noise on it, or hardly any noise on it, which is great, like electric noise. It's far away enough from the house as well. To step over the control wire here. Of course, I forgot to bring my remote termination, so I had to. Luckily, I had my backup with me. My backup is just like a, variable pot. I can show you here. So this is, terminating from 817 to 1318 ohms. To be able to set it correctly, I actually had to take my computer out into the field. Put on my hotspot on my phone to get connection, and then used TeamViewer to look at my computer over there 500 feet away, and then most carefully turn the knob on this thing and make sure that I hit the right termination. There's actually a 3-turn wire wound pot that I put in here, so I can, it's nice fine tuning as well. But that's the Supercast. It's just like one big huge delta loop, and that's the DCAS, and that's how we do our business. And that's the house that we do our DXing in. So hope you enjoyed it. After you, if you ever want to come with us on one of these DXpeditions, then make sure to hit us up. All right, signing off. K7JBT 73.